The prototype pattern is a creational design pattern that allows objects to be copied or cloned, providing a mechanism to create new instances by copying existing objects without explicitly invoking their constructors. And it's used to efficiently produce new instances with identical properties to existing objects. So say that we have a GUI, a graphical user interface, that allows the user to create new shapes on the screen, such as circles and rectangles. When the user right-clicks on a shape, an Actions menu opens up, and the user can then select Duplicate to clone the shape. So you can see here we have the original shape on the left. If the user right-clicks and then clicks on Duplicate from the Actions menu, the shape is duplicated and rendered on the GUI. So let's come up with a solution to this problem. So you can see here we have a shape interface with a draw method, and then we have our concrete shape classes that implement this shape interface. And then we have a shape actions class that contains the logic for duplicating each shape. And this duplicate method and this shape actions class is dependent on all of the shapes that can be duplicated. So you can see here that we can see that this class depends on all of these concrete shapes, and that's represented by this dotted arrow. So can you see the issue with this solution? And can you also spot what solid principle we are violating? And as we code out this solution, the issue here is going to become very obvious. So let's go ahead and do that. So first of all, let's create a new folder for our creational design patterns part of the course. And then we'll create a new folder for this prototype pattern. Okay, so first of all, let's create the shape interface. And this is going to have a single method called draw. Now let's create a few concrete shapes. So let's first of all create a circle. And this is going to implement the shape interface. Okay, so we have the draw method here. And let's just log here drawing circle. Okay, so we also need to give the circle a property for its radius, because all circles need to have a radius. So we'll say public int radius, and then we'll give it a getter and setter. Okay, so they're nice and simple. And I think what we'll do, so whenever the user sort of creates a circle on the screen, so if they click, a little circle icon that produces a circle to appear on their canvas, then I think it would be nice to give it a default radius. So let's give it a default radius of 5 for all newly created circles. Okay, so next up, let's create the concrete rectangle shape. And again, we implement the shape interface, and all rectangles have a width and a height. So let's go ahead and give it a width and height property. And also a height. And again, let's give it a default height of 10 and a default width of 5 and a default height of 10. Actually, no, we'll go with 10 and 5. Okay. Okay, so let's just log drawing rectangle here. Okay, so that's all we need to do for our shapes. So now we can create our shape actions class, which is going to depend on all of these concrete shapes. Okay, so let's create our duplicate method, which is going to accept a shape. So it has a shape parameter. Now in here what we need to do is we need to duplicate any shape that's passed into the duplicate method. So first of all, we need to actually check what the type of shape what type of shape has been passed in. So we can say if shape is circle first of all, and let's see what's going on here. The type namespace circle could not be found. Let's see, I've misspelt circle here, so let me correct that. Okay, and that fixes the issue. So let's see, so first of all, let's cast this shape object into a circle. So we'll call this copied shape, so the shape that we are copying, and we'll cast it into a circle. And that's how we cast, and again I spelled circle wrong, there we go. Okay, so now we will create our new shape, which is going to be the clone. So I'm just going to make a note, this is the copied shape, and then we will have our new shape, the duplicated shape. Okay, so we create a new circle, and this is the clone. And then what we can do is we can set the new shape's radius equal to the copied shape's radius. Okay, and then we can draw this shape onto the canvas by calling the draw method. And then we also need to check if the shape is a rectangle. And if it's a rectangle, again, we're going to create, we're going to cast the shape into a rectangle. Okay, so now we can treat this shape as a rectangle. So we also need to create our new shape, or our clone. This is going to be a new rectangle. And then we can set the new shape's width and height equal to the passed shaped, the passed in shape's width and height. So we can say new shape dot width equals copied shape dot width, and we can say new shape dot height equals copied shape dot height, and then we can draw the new shape onto the canvas. Okay, so it would also be a good idea to check at the end here. So if the shape is not a circle or a rectangle, then we could just throw an error. So let's do that. So we'll throw a new argument exception, and we'll say invalid shape provided. Okay, so we can't duplicate a shape that isn't a circle or rectangle in our current implementation. Okay, so here's how a client would use this solution. So let's go ahead and show you how this solution would be used. So we can create a circle, and I cannot spell circle today, so let's create a new circle, and let's draw that circle. So render it onto the canvas, and then let's simulate the user clicking the circle and dragging to resize. So this is like user clicks and drags to resize. So we can say circle dot radius equals 12. So we increase the radius, and let's say that a user adds a new rectangle to the GUI. So I'm just going to copy and paste this in for now to save a little bit of time. So we can see here we create a new rectangle, draw it onto the GUI. So this is like the user adding a new rectangle to the GUI, and then the user clicks and drags the rectangle to resize the width and height. So now let's take a look at how we could duplicate these shapes. So let's simulate the user right clicking and clicking and selecting duplicate. Okay, so we can simulate that. So shape actions equals new shape actions, and then we can call shape actions dot duplicate and pass the shape that we want to duplicate. So if we want to duplicate the circle, we can do that. If we want to duplicate the rectangle, we can do that. Okay, so let's run this program to see if everything is working correctly. And as you can see, we are drawing the circle and rectangle onto the GUI. So that's these two methods here, so circle.draw and rectangle.draw. And then we duplicate the circle, so we draw the circle again, and then we duplicate the rectangle, so we draw the rectangle again. So this is all working correctly. So hopefully by now you have spotted the main issue with this solution, and it should be pretty obvious that the issue is in this duplicate method. So here are some of the obvious issues that I can spot. So first of all, we are violating the solid open close principle, as we need to modify this shape actions class every time we add. So that means extending our code base a new shape. So whenever we add a new shape, we're going to have to modify our existing code, because we're going to have to add a new conditional block of code to check for this new shape and add the logic for duplicating that particular shape. And you can also see that shape actions is coupled to the concrete shape classes, and so far that's circle and rectangle. So you can see it's coupled because we're calling the new keyword here. And so shape actions has to know about or depend on all kinds of shapes and their specific fields and methods. So you can see here that this shape actions class has to know that circles have a radius field, and it has to know that rectangles have a width and height. So it has to know about the specific implementation details of each of these concrete shapes. And at the time of writing code, shape actions has to know about all of the shapes that we support. So what if we wanted to make this app extensible so that other developers or other people can build plugins for this application, so that they can define other types of shapes that can be added to the GUI? And that can't be achieved with this current implementation, because at the time of writing code or at compile time, this shape actions class has to know in advance about all of the types of shapes. So this is not a flexible solution, and it currently depends on concrete implementations of shapes. So let's now take a look at how we can solve the issues that we found previously. So the logic for duplicating a shape can be moved to each concrete shape class, rather than having it all in the shape actions.duplicate method. So in other words, we can move all of this duplication logic for a circle and add it into the circle class, and we can do the same for rectangle, put it all into the rectangle class. Okay, so we can then decouple shape actions from all of the concrete shapes and have it talk to the shape interface, which is much more flexible and maintainable. So note how the shape actions class has been sort of lifted up to talk to the single shape interface, rather than having it talk to many concrete classes. So you can see beforehand it depended on the many concrete classes, because we had to check what the type of shape was before duplicating it, whereas now it's been lifted up to talk to the shape interface, and we've added the duplication logic for each shape into its own class. Okay, so let's have a look at the gang of 4 representation of the prototype pattern. So here you can see we have the prototype interface with the clone method, and then the concrete prototypes implement this clone method. So each concrete prototype knows how to clone itself, rather than having this clone logic inside of some sort of client or other class as we had previously. And this means that the client can use polymorphism and talk directly to the prototype interface, rather than talking to the many concrete prototype classes. So let's now implement this solution in code. Okay, so now let's refactor our code to use the prototype pattern. So the first thing I'm going to do is I'm going to change, I'm just going to add an extra method to the shape interface so that all shapes can be duplicated. And you can see the duplicate method is going to return a shape. So next up, we need to solve a few errors that we're now getting. So you can see here that circle does not implement interface member shape.duplicate. So we need to implement this duplicate method. So we've already created the duplication logic beforehand in our shape actions class. So what we can actually do is we can copy this here. So we can say new circle and shape.radius equals copied shape.radius. So let's add that into circle. And you can see here that we don't need to reference this copied shape anymore. We can just use the radius field directly on circle. Okay, then finally we need to return this new shape. Like so. So here we create the new shape to clone, and then we just set the radius equal to the current circle's radius and return that new shape. Okay, so new circle. And let's actually rename this now to new circle. Okay. So next we need to do the same thing for rectangle. So let's implement this shape class. So we need to add the duplicate method, and then we can copy and paste the logic for copying a rectangle. So let's add that in, and we actually need to create a new rectangle. Okay, so we create a new rectangle, and then we set the width and height equal to the current rectangle's width and height. Okay, so let's again change the name of this to something a little bit more specific. So new rectangle, and then we need to return this new rectangle from the duplicate method to satisfy the method signature. Okay, so that's everything we need to do in the concrete shapes. So now we can go to our shape actions class, and we can see here this very bloated, ugly method can now be refactored into something much cleaner. Now all we have to do is return shape.duplicate. Okay, and we're actually going to return a shape this time from the duplicate method. So I'm just changing the kind of implementation details a little bit here. So rather than drawing the shape onto the screen, we're just going to return the shape and allow the client to decide what they do with that duplicated shape. Okay, so I'm just also going to log, just so it's clear, duplicating shape, just so it's clear what's going on when we run the program. Okay, so now let's go into our client and see what happens if we run this. As you can see, everything seems to be working correctly. Okay, so what I want to do here is, because now duplicate is returning the new duplicated shape, let's see if we can, let's see, new circle equals that. So now we can store this return shape in a variable. So let's say shape new rectangle equals that. And then we can decide in the client whether we want to draw it on the screen or do whatever we want with this new cloned or duplicated shape. So let's actually draw it. So this is basically now doing exactly what we had beforehand. We duplicate and draw the shape on the screen, but we're now controlling whether we draw it or not in the client. So it's just a slightly different implementation detail that gives the client a little bit more control over what they do with this duplicated shape. So let's run this now. And I think what I'm going to do is actually duplicate, create the new circle, then draw it, just so it's a little bit more clear. Okay, so we can see here, we first of all draw a circle, just the same as before. We then draw a rectangle. We then duplicate the circle. We then draw this new duplicated circle on the screen. Then we duplicate the rectangle and draw the rectangle on the screen. Okay, so this is all working perfectly, and we can now also add new shapes without having to modify existing code in the shape actions class. So the great thing about this prototype pattern is we are now satisfying the open close principle, because we can create a new shape such as a triangle and we don't have to modify any existing code.